In this video, we will learn some important reactions of haloalkane. First reaction is when an alcohol, say ethanol, react with red phosphorus and halogen. In halogen, it may be Br2 or Cl2. Then the product is haloalkane. Second reaction is when an alcohol react with PCl5, phosphorus pentachloride, it forms chloroalkane. So here from ethanol to chloroethane is formed. Next reaction is when alcohol react with SOCl2, this is called thionyl chloride. It gives chloroalkane. So the product is chloroethane. When an alcohol react with concentrated HCl in presence of ZnCl2, it forms chloroalkane. Here the product is chloroethane. The reagent concentrated HCl and ZnHCl2 is also called Leuker's reagent. Next is when an alkene react with hydrogen halide, it forms iodoalkane. It is an addition reaction, and the addition of hydrogen halide takes place according to the Markovnikov rule. What Markovnikov rule says? It says that when there is an unsaturation, means when there is an carbon-carbon double bond or carbon-carbon triple bond, then the negative part of hydrogen halide, that is this I, goes to that part of carbon which has less hydrogen, and the hydrogen goes to that part of carbon that has more hydrogen. So the product is this. The name of this product is 2-iodopropane. Next reaction is if you add peroxide in the above reaction, then the addition takes place according to anti-Markovnikov rule. What anti-Markovnikov says? it says that negative part will go to that part of carbon which has more hydrogen, and positive part goes to that part of carbon which has less hydrogen. So this is opposite to the Markovnikov rule, and it is now the product is one bromo propane. Here you must note that addition of hydrogen halide in presence of peroxide is only takes place with hydrogen bromide. Next reaction is when an alkene react with Br2 in presence of CCl4, then addition of one bromine takes place to each of the unsaturated carbon. So the product is like this. Next reaction is when an haloalkane react with aqueous KOH, then substitution reaction of Cl with OH takes place and the product form will be alcohol. Next reaction is if an alkyl halide react with alcoholic KOH, then the substitution reaction do not takes place but the elimination reaction takes place and the product is alkene. You can write here like this Cl and one H here, it will remove by alcoholic H and the double bond is formed between these two carbon. So you note here that if you take aqueous KOH, then substitution reaction takes place, but if you take alcoholic KOH, then the elimination reaction takes place and the product is alkene. Now if you take this haloalkane with alcoholic KOH, then there will be a major and a minor product. What will be the major product? The major product is, say this is alpha carbon and this is beta and this is beta. Now hydrogen removed from beta carbon. So there is a possibility to remove from hydrogen from CH2 or CH3. Now according to Sedgwick rule, the removal of hydrogen takes place from this hydrogen. Why? Because according to Sedgwick rule, it says that the alkene form, the more substituted alkene will form in this reaction. So the two product we can write here. This is one of the product, two substitution here across the double bond, and another one is this one is the minor and this is the major product according to Sedgwick rule. Next reaction is when an alkyl halide, say bromoethane, react with KCN, potassium cyanide, then it form CH3, CH2, CN. This is called propane nitrile. This is a substitution reaction. Here you see bromine is substituted by CN. Next reaction is when an alkyl halide, say bromoethane, react with AgCN, then it form isonitrile. This is CH3, CH2, and C. So name is propane isonitrile. Here you see in propane isonitrile the bond is formed between carbon and nitrogen, but in nitrile the bond is formed between carbon and carbon. Next reaction is when an chloroethane, any alkyl halide, form with AgNO2, it form nitro compound, and here is nitroethane. Here it is one of the example of substitution reaction. Cl is substituted by NO2 and the product form is nitroethane. Next reaction is when an alkyl halide, say chloroethane, react with a reducing agent LiAlH4, lithium aluminum hydride, it gave alkane. Here in chloroethane 2 carbon is there, so in the product 2 carbon alkane is formed, so the product is ethane. Next reaction is when an alkyl halide, say bromoethane, react with magnesium in presence of dry ether, an organometallic compound called Grignard reagent is formed. Here the Grignard reagent is ethyl magnesium bromide. The next reaction is this ethyl magnesium bromide that are formed in the above reaction will react with water to give alkane. Because this ethyl magnesium bromide is very reactive and you have to prepare this in anhydrous condition. This Grignard reagent when react with water, it form alkane. So the product here ethane.